The following is a video on the steps required to prepare a primary standard solution of sodium carbonate and how to use that sodium carbonate solution in a titration to standardize a hydrochloric acid solution. A standard solution is a solution with an accurately known concentration. A standard solution can be prepared using a primary standard. A primary standard is a solid, acid, or base which can be weighed accurately so the moles can be calculated. This solid must be pure, readily soluble in water, and stable so as to not react with the carbon dioxide and water in the air. In this case, we will be using anhydrous sodium carbonate as the primary standard. The method to produce a primary solution goes as follows. Firstly, weigh approximately 2.6 grams of anhydrous sodium carbonate in a clean, dry 50 milliliter beaker on an electronic balance. Be sure to record the exact mass of the weighed sodium carbonate. To be certain that the solid is anhydrous, that is, that the crystals contain no water, the beaker must be placed in an oven for roughly 5 minutes. Weigh the beaker again. If it reads as the exact same mass as previously recorded, the solid is anhydrous. If not, repeat the heating process until weight is constant.
Next, add deionized water to the beaker and carefully dissolve the sodium carbonate using a stirring rod. When finished, rinse the stirring rod with deionized water into the beaker to avoid any loss of sodium carbonate. The dissolved sodium carbonate must then be quantitatively transferred to a 250 milliliter volumetric flask using a clean glass filter funnel. Repeatedly rinse the beaker previously used with deionized water, emptying the contents into the volumetric flask until the bottom of the meniscus is at the engraved 250 milliliter line. Place a glass stopper on the top of the flask and invert to ensure equal concentration throughout the solution. A label should then be placed on the flask indicating that it is a sodium carbonate solution along with its concentration. Its concentration is calculated by dividing the number of moles of the anhydrous sodium carbonate with the volume of the solution, which is 0.25 liters. Record the exact concentration on the label correct to 3 significant figures. A standard solution has now been prepared with an accurately known concentration. In the next step, we use this solution to find the concentration of the hydrochloric acid by titration. Titration is a volumetric analysis technique used to determine the exact concentration of a solution by reacting it with a solution of a known concentration. The following steps are taken in this method. Firstly, wash a 25 milliliter pipette with a small amount of the prepared sodium carbonate solution. Do not wash it with water as it may change the concentration of the solution. Discard the washings into the sink. Now, fill this pipette with 25 milliliters of sodium carbonate solution using a pipette filler with the bottom of the meniscus just touching the line. Next, transfer the solution by draining it into a clean conical flask that has been previously washed with deionized water. Dry this conical flask so as to not let any deionized water interfere with the concentration of the sodium carbonate solution. Be sure that the tip of the pipette makes contact with the inside walls of the flask to ensure that all of the solution is transferred but the last drop. Then, add 2 to 3 drops of methyl orange indicator to the solution in the flask. Methyl orange is used because we are titrating a strong acid with a weak base, and therefore the color change should fall somewhere between pHs 3 and 5. The volume of the sodium carbonate solution in the flask is now called the aliquot. The methyl orange is yellow in sodium carbonate base. Next, wash a 50 milliliter burette with deionized water, then the hydrochloric acid solution whose concentration is unknown. Do this using a filter funnel and be sure that the bottom tap is closed. Once washed, allow the solution to drain out into the sink by opening the tap. After this, fill the burette up to the 0 line reading from the bottom of the meniscus. When filling, at first leave the tap open for a few seconds to ensure that no air bubbles are caught at the bottom of the solution. The burette is now attached to a retort stand using a clamp. The conical flask is placed under the burette. A white towel is then set onto the flask so that the color change of the indicator can be clearly seen. Next, run the hydrochloric acid solution into the flask carefully while swirling the flask until you find that the yellow color is turning red. When this happens, very slowly add the hydrochloric acid solution drop by drop. Stop adding a solution when the red color does not disappear from the mixture even after swirling. Record the volume of the hydrochloric acid solution it took to get to this stage. This is called the endpoint of titration. The first titration is a rough titration. Repeat this process using the same sodium carbonate solution you prepared as your standard solution 3 times. The conical flask needs to be washed with deionized water for each new titration. If all 3 results are not within 0.1 milliliter proximity, repeat the titration process.
Average the 3 similar results and with the mean volume, calculate the concentration of the hydrochloric acid by dividing its moles by its volume. Once calculated and the concentration is known, the hydrochloric acid solution has then been standardized. Label its container with its accurate concentration value, as it can now be used to find the unknown concentrations of bases such as sodium hydroxide.